So there we got 3 ways that it is possible to create preorganic molecules. Came from outer space. It's a cop-out answer, but it could happen. A reducing atmosphere, and geothermal vents. Stage 1, done. Stage 2. We have to polymerize the nucleotides or the amino acids. We've built our nucleic acids, we've built our amino acids, now we have to get them to form these much larger, more complex molecules. And there's a big problem. Water. We talked about condensation reactions. Condensation reactions build molecules. But what's the opposite? How do you break them apart? Hydrolysis. And when does hydrolysis happen? In the presence of water. So when you've got water around, you're constantly breaking bonds. And of course, where are all these preorganic molecules? In the water. So the issue is, as much as you want to form these polymers, water is breaking them down just as fast. You need to have the rate of polymerization of condensation reactions to be higher than the rate of hydrolysis reactions. And again, the prebiotic soup is made of water, so this slows down the reactions. So here's how we can get around that. Here's how experiments have shown that it is possible for polymerization to occur for the rate of hydrolysis to be slower than the rate of polymerization. The first hypothesis is the imbued clay hypothesis. The entire world is not made of oceans, right? There are shorelines. There are areas where the ocean meets the sea. Now, if you look at these oceans where they meet the sea, what happens at the beach? What's happening in the water? Not trying to trick you. Waves. Waves splash the land. We've all been there. Well, maybe you haven't. But it's the idea that waves are constantly splashing up on land. If they are splashing up on clay, and that is not a unreasonable assumption, because sand is just broken down rocks. Clay is just very fine particulates. Probably got some iron in there. There's a lot of iron that's been coming out of the earth. If water splashes up onto this clay, what happens when water hits a porous substance like clay or sand? It sinks through it, right? I wish I had some sand to show you. If I pour water on sand, that water goes right through. The thing is, though, if you have that clay, you're getting the water splashing up, the water sinking through, but leaving behind the dissolved bits, the preorganic molecules. I'm sorry, the amino acids and such. If you've got that happening, or if it splashes into a pan, and it's not a real pan, a pan of clay, the water might evaporate fast enough that polymerization can occur. And the reason I'm talking about clay is because clay has been shown to bind nucleotides and amino acids. Clay holds on to nucleotides and amino acids. At the same time, clay is able to attract metal cations, and metal cations catalyze polymerization reactions. Do you guys remember what it means to catalyze something? Other way. Speed up the reaction. I think you're saying by reducing the activation energy. Yeah, it speeds up reactions. It makes them go faster. So if we've got clay around and we splash this water full of molecules onto the clay, that clay will bind the molecules and start help stick the molecules together. So the clay hypothesis is totally reasonable. We have shown that it is possible for that to occur. But it's not the only way. Because it turns out there's a 2004 study that showed it was possible for polymers to form in an aqueous solution, or an aqueous solution. What's an aqueous solution? Yeah, it's got water. It's possible for these reactions to occur if carbonyl sulfide is present. carbonyl sulfide will exclude the water. It'll stop the water from interacting with those polymers. Okay, so here's the cool part. Where do you think we can find carbonyl sulfide in an aqueous solution? Sorry, it was cool to me anyway. Here's the thing. Carbonyl sulfide's present at geothermal vents. So at the same place we could be building these molecules, we can also be forming polymers. So we've got everything that we need to create these organic polymers from start to finish at the geothermal vents.